So good morning everyone. I am Ananamati from the fourth year cybersecurity department of computer science engineering. So our project is taught to text using I only signals. So we are going to under the guidance of Gauri Ganesh. So he is our associate professor of department AIDS. Let's get to the introduction. So make it simple. I'm going to make it simple what we are going to do and for whom it's very helpful. So we are going to do um, a text using I only signal detection. It's like the person who are not able to speak, who get paralyzed due to some effects like ALS or lock syndromes. For them, they can't able to speak, they can't able to do some actions. For them, we are just creating a software which is fully based on using I signals and convert it into text, and with the use of camera we are going to build this software. And this is very cheaper because there is existing solutions out there for this kind of peoples, but it's more costly and expensive. So we need a low level cost of product to get every kind of peoples. Next, the problem statement. Problem statements with existing communication system often requires a physical interaction, which is not possible for paralyzed or locked in patients. Brain-computer interface solutions are invasive, expensive, and complex to incomplete. Manual and courageous department communication methods are slow and inefficient. Many assistive technologies lack real-time performance and adaptability. There is a need for a non-invasive, affordable, and efficient system that converts. Okay. Scope of the project. Scope focus on developing a non-invasive activity assistive communication system using eye only signals such as eye movement and blink patterns. Utilized camera based eye tracking or EOG sensor to capture eye signals without requiring physical interaction conditions. Okay, target audience individuals with severe motor and speech impairments, ALS paralyzed, lock-in syndromes, and caregivers and rehabilitation center. Deliverable: a functional eye signal to text conversion systems, a trained and evaluated eye signals recognized a model, a simple and accessible user interface for the text display and the interactions. So these are the scope of the project. So how the data is used and limitations and model generalization, expert validation, and computational resources like a machine learning model process eye signals into real time may require a modern computations request. Okay, what's the methodology that we are going to use in this project is eye signal acquisition, data processing, eye feature extraction, eye signal classification, virtual keyboard development, text generation, and output system integration and test. So this is our architecture diagram that how our product is going to work, in what way it's going to work and detect the patient's actions. So we can see the data perceptions, camera sensor, and it will go to eye perceptions, noise reduction, ROI, and eye feature extraction goes to eye, landmark and gas vectors, though this is the processing engine. Then it will go for signal classification and then go for text generation. So these are the steps that included in our project. Okay, then design use case. So this is our design use case of how the product is behave for our users. So it's a class diagram. Also thousands of students attend the university. You would only model of one class called student. So what is Sage? Using patient, collaborate, like that, everything it was given in the admin, caregiver. So first user, admin, center is login. So this was the main functionality of our product. So it's a sequence diagram. The person and the perform blend gas will go for a camera sensor, and then capture frames will go for a signal processing system, and then virtual keyboard, it will go for a virtual keyboard UI. So then the re-receivers, this will go for and then the classification signals and etc. And capture frames and capture frame happens to text buffer, display generation, and confirm blink SL. Okay, algorithm used. The algorithm used in our project is OpenCV based eye detection algorithm. So users Uh, it provides a fast detection performance and reliable results under control of lightning conditions. Blink detection algorithm using OpenCV image processing technique to identify eye open and closed status. Blink detection is performed by analyzing changes in eye region, pixel intention, and shape. Algorithm use eye movement tracking algorithm and text converting algorithm. So these are the two algorithms that we have used in our project. And hardware and software selection. Hardware requirements: camera, computer, and lightning scope and display monitor. Software requirement: operating system or Windows, Linux, Mac, and then for program language is required Python. Software requirements: OpenCV library used for real-time eye detection, tracking, and blinking detection. NumPy used for numerical operation and image processing. Machine learning libraries optional. And then IDE development, so like VS Code, PyCharm, Jupyter Notebook, whatever the environment you want, you can choose. Implementation: the project is implemented by Python using the following libraries: OpenCV and PyTorch. The project includes Python script that can be used to detect an image fields. So these are the codes that we have used for our project. I controlled virtual keyboard interface output. This was our GEU, how the text is formed. So this is our output, that what we have get with the use of the OpenCV and this test case. These are the test case that we have used in our project. So camera installation, face and eye detection, blink detection, eye movement detection, text general, and display. For e-commerce type of our project, we have given this test case. The admin uploads product into your website, customer search for products, user gives reviews to the product, and the user gets the overall review for the product, and user buys the product. These are the test case that we are given for the e-commerce type of project, and test result came for 3 out of 5 because user gave review wasn't not given for our product because we didn't even publish our project properly. We just applied for the patent. So once it approved, we'll give it as a whole product into the industries. So this was the result, that machine learning, accuracy, precision, and recalls. And then just we came to the conclusion in this project. The experimental results demonstrates the eye only signals such as eye movement, blink pattern can be efficiently used to convert using institutional reliable. This project provides a non-invasive, cost-effective, and assistant communication solution for individuals with severe motor and speech impairment. So in future, we will explore the integration of deep learning based eye tracking models and multi-language text supports to enhance usability. Additional, the system can be extended to the support speech synthesis and integration with assistive device or a smart environment will enable richer and more natural communication for users. These are the reference that we have taken before we get into this project. So thank you once again. Thank you. That I hope you guys will understand what our project is going through. Thank you.